Good to start. Hello everyone, my name is Panagiotis, Panos for short, and I'm going to be presenting alongside Diana today about a threat actor we've been tracking that was using very interesting techniques, active and evasive, and he was migrating through different infrastructure. A bit about ourselves. We are part of the Mandiant Managed Defense team, and our purpose is to help organizations stay safe from different cyber attacks through different methods like hunting or monitoring active alerts, and work with them to mitigate the risks. As you can understand, we are dealing with high volume of alerts daily, and this was one of the cases we came across that was standing out, so we thought we'll put some research out there. So a bit about the structure of the presentation. We're going to start initially on how everything started from a simple report that was sent out to the client, how we moved our research into an open source intelligence. Then and Diana will cover some more information about the malware we've seen and the capabilities. The threat actor that constantly moving between the different infrastructures and using public websites for sending the malware to infect the hosts. And we're going to close the presentation and allow some time for questions. So it all started after a client commented on one of our reports. To what appeared back then, it was a worm infection. So as you can see, the report had an initial infection in the USB, and then the user clicked the normal link file that would appear there, but the link file had a pointer to execute an explorer.ps1 script that was also sitting on the USB that was hidden as well. And when I was checking the report, I've seen an interesting connection out to Vimeo. For those who don't know, Vimeo is like a video hosting platform, and it was quite popular for myself. I knew it from older times, and then I've seen the PowerShell script writing some files on the host, and from there I went back, hopeful with some hope that I will get the script to see what was going on and why it was calling out to Vimeo. Lucky enough, I managed to get this, and as you can see, it's base64 encoded, and there is, at the end, there is a reversed operation, which I can't remember seeing that before in an administrative legitimate activity. So that was getting more interesting for myself. I started decoding the activity, and I came up with this script. It's an obfuscated script. As you can see at the bottom, there is clearly an decryption routine. And just before I move to the decrypted part, I want to point out the 44 WK equals characters there. That's when decrypted, it decrypts to a Hangul filler, which is an invisible character, and it's from the Korean alphabet. So it's something similar to space, with a subtle difference. This is allowed by the Windows operating system to create a character, so it allows you to create a folder under an invisible character, so it's not visible to the human eye. So as you can see, the decrypted part, it was calling out to Vimeo, to some resource of the video, JSON object, and then it was pulling down additional stuff. And you can see some regex between the last line about the acquisition of the encrypted stuff that we were going to see in the next slide. So I went ahead and I pulled the JSON. There you can see between the semicolon and the question mark, the encrypted payload. And because this is just, it was the API, I went ahead and I've seen the video as well to see how it was looking back at the time. And as you can see in the description, the encrypted payload is still there, hidden in plain sight. So the script will then pull the encrypted payload and decrypt it into another yet encoded string. And again, we follow the similar process. And you will identify additional files and another domain as well. And the runtime broker saved into the temporary directory. Another interesting file we've seen was the from machine UUID at the bottom, which later we found out that this was used by the threat actor to track an infected host. And then we moved into a hybrid approach. So we used our findings to identify any missing detections opportunities in the client environments that this evasive malware was hitting into, and some open source intelligence. From there, we've seen two files named as runtime broker, one in between, having the space in between the runtime broker and one at the end. We identified additional files. The program PyZ is like an archive file of Python scripts, and the bootstrap PYC file. One of our infections, we've seen the malware dropping CoinMiner, which Diana will touch more on about the malware itself later on. From there, we used all our findings and we moved it into open source intelligence. We identified samples since 2021. And we had, as a side note here, we had an inside joke. Diana will cover as well the malware part, that this was inspired by a threat actor during COVID. So you'll see one of the modules that it was using some references as well. I'm gonna move to the next part, which is gonna cover the 2021 sample, which was the earliest we've managed to find. This was a very similar structure. As you can see, the characters at the top are very simpler, A, B, C, D, and you will see it calling again to public websites. For the second stage payload, it was using GitHub for this one. And we went ahead, and luckily enough, we found the resource there. And this was another great example of the threat actor trying to be evasive and heading into plain sight. As you can see, to the left, there is a hex representation of the file. If you see this in the text editor, it's going to be empty. So this is a combination of space, tabs, and new lines. But once you decode the whole scheme, it ends up with zeros and ones. And it codes to this another domain, which is used further to download the runtime broker. Then we moved on to the other file we found, 2022, yet another domain there about downloading additional files on the host. And then we moved also on to the PyZ files. As you can see, a lot of the submissions we observed there were from first submission in Italy. So we had an idea that our threat actor was targeting people in Italy and from different posts as well. So we moved our research to different blogs and sites that people were having similar issues. And this is the next one as well is a well-known website that people were mentioning that they were having issues with their USBs and some kind of virus. This is an Italian site. This is a few examples, and this is another one. We've seen a lot of Italian websites, so this was backing up our understanding about the threat actor. And I'm gonna pass on to Diana to cover the malware.
Thank you, Panos. Hello, everyone. So now about malware, the malware analysis part. We'll start with the first file that we saw downloaded by the PowerShell script, which is runtime broker. We named this file EMPTYSPACE. It's pretty obvious why, because there were a lot of empty spaces used by the threat actor. And through various means, open source research or pivoting through the various IOCs we found, we identify 3 different versions written in multiple programming languages. So we have Node.js, .NET, and Python. We won't go into much details for each version, but only highlight some differences and functionalities. So the first two, Node.js and .NET, are quite similar in functionality. Both act as downloaders. They can check the mounted drives and only proceed with the infection in case the Hangul filler name directory is found on the mounted drive. Both communicate with the same C2 server, which you have right there, if I can use this. No, that's hard to use. The same C2 server is there, and they use the string C installer. The first sample uses this to refer to itself in the communication with the C2, while the second sample uses the C installer string in the name of the mutex it creates. And both of them can run with elevated privileges as well. On the other hand, we have the Python version, which is a lot simpler. It only checks for internet connectivity by trying to contact the Google domain. It then loops through a list of predefined servers and tries to send a post request to these remote servers. And the data is formatted in this post request exactly as it is in the .NET version, so similarity there. And what's more about the Python version, I can show you the code actually. And you see on the second line, there is the bootstrap version variable set to pybootstrap 4. And I wondered, well, if this is 4, there might be 3 bootstrap version 2 or 1. And through this, I actually found the previous 3 versions. And all of them had the same code, but a different list of domains. So in the included list there were different domains. And next we have the program.py malware that Panos mentioned. We named this quiet board. And this one is actually a modular multi-component backdoor written in Python. It has several different modules, each one responsible for a different functionality. And as you've seen on the previous slide with the search MVT for this, there are multiple versions of quiet board as well. And the earliest one we found around 2021 only contained just the Corona USB module, so the functionality to infect removable drives. And this goes back to the inside joke Panos mentioned about this malware maybe being developed during lockdown. And the last modules that were added to the backdoor were the C board and run service. So the one responsible for stealing crypto, and the C2 communication with fetch and execute, which is the capability to run arbitrary commands on the host. And we'll look a bit more into the code for the Corona USB module. Just to notice there is the variable empty character holding the Hangul filler character. And the variable USB read PowerShell, where the threat actor is actually constructing the explorer.ps1 PowerShell script. And you see different functions. It starts in the start function that runs in a loop, and it's continuously monitoring the host for new connected USB drives using the locate USB function. And whenever a new USB is found, it calls the create hidden folder function, which does all the magic. It creates the hidden directory using the empty character variable, so the Hangul filler name. It then writes explorer.ps1, but just before this, it creates the LNK file that will execute the PowerShell script when the user double clicks on it. And next we have the Seaboard module. This one will essentially run in a loop as the previous one, and try and monitor the clipboard content. And whenever new strings are detected in the clipboard, it will call the replace function, which will try to match the clipboard content with any of the patterns that you see in the regex matches list. And in case any match is found, it will replace the clipboard content with the corresponding string listed there. And those are actually blockchain addresses. So the first one is Monero, the second one is Ethereum, Dogecoin, and the last one is Bitcoin. And an interesting fact here, the Bitcoin one, I just searched for it on Google, and I found it mentioned in various places not really related to crypto. So for example, in PowerPoint presentations or URLs from various universities, PhD thesis, master thesis, all related to Italian universities. And this just shows like the spread of the infection in the Italian peninsula. And here I just wanted to show you the balances in these wallets. Of course, I cannot show you Monero since it's private. The balances are not very high, but the volume transacted through these addresses is quite much more than what is shown here as of last month. And now, why we thought this was like a cat and mouse game from our perspective. So we noticed that the wider security community started picking up and posting about this infection chain. You have here a post from X explicitly calling out the payload on Vimeo, and eventually Vimeo took down the video. And we thought, okay, we might see a slowdown in the attacks after this. It takes time, right, to rebuild the infrastructure, but fear not. Our attacker quickly switched to Ars Technica, a technical forum, and what he did there, he or I don't know, they created a profile, and in the About section, you see there a pizza, another link to our Italian angle. In the URL of the pizza image, you see embedded the payload, which has the same delimiters as the one on Vimeo, the columns and question marks. And we were in the last stages of our research for the blog that we published about this activity. And when we noticed this shift, we had to notify Ars Technica. They were really quick in their response, and they took down this user and the payload. And then we published our blog. I encourage you to read it. It's quite detailed. And again, we thought that the infections might stop and the attacker might just be quiet for a little longer. However, a couple of weeks after we published the blog, we started seeing infections again. And now they were using a different PowerShell script. The structure is the same. It's still using IIS encryption and decryption. However, the key is not hard-coded in the script anymore to decrypt the payload there. It's generated using the identifier of the USB device, and this makes analysis a bit more complicated if you do not have access to the USB device. You can still try to brute force the identifier. It's not very long, but still it's a bit more complicated. However, the EDR solutions that we use in our investigations managed to capture the decrypted script in the memory. And we saw it was reaching out to a WordPress domain this time. And we went there and we saw this page, likely created by the threat actor, and hidden there in a hidden div element in the HTML code, you have a similar payload. They kept the same structure, probably for backwards compatibility with the rest of the PowerShell script. Next, we have here the full infection chain that I can finally show it to you. It starts with the infected USB drive, then the user clicks on the LNK file that triggers the PowerShell script. On the left-hand side, you have the older domain, the older infection chain where the intermediary payload was hosted on GitHub or GitLab. And it was using the custom decoding scheme to obtain the final payload from where EMPTYSPACE was downloaded. And on the right-hand side, you have the more recent infection chain with the intermediary payload hosted on Vimeo, Ars Technica, and WordPress. And now it's using the IES encryption and to obtain the URL and then still downloading EMPTYSPACE. And after EMPTYSPACE is on the host, essentially the attacker has a downloader and he can basically download anything. But what we've seen is the coin miner and quiet board. And with quiet board having the functionality to spread the PowerShell script, you have like a full circle going back to the infected USB drive. And finally, we have some takeaways from our investigation. What was really interesting to see is how the threat actor treats their malware like any other software product, right? It goes through multiple stages of starting with basic functionality, and I'm thinking here of quiet board, for example, and then adding more and more modules as time passes. And yeah, there was a question, maybe they're using Agile, who knows. We can also see an evolution going from just a custom decoding scheme to IES encryption, and also versatility in using multiple different programming languages. This could also mean that maybe we are dealing with multiple attackers, but it's just suppositions. And as a recommendation, of course, we would encourage you just to stay away from USB devices because you don't know the status of the host you are plugging the USB in. And like whenever you need to transfer files, maybe consider using Google Drive. And now we'll open the floor to questions.
What's the defense for this recommendation from side?
So if you go on the blog, we posted many Yara rules there, and I think many of the major vendors are now detecting this. What I actually didn't mention, and I should have, is that during the investigation, we went back through our clients, and we actually found that this infection is really, really stealthy. So the hosts were infected for months, and even in some cases more than a year before like any alert was triggered. And yeah, in one particular case, we went and through hunting, we found that the host was infected, but there was no alert whatsoever in there. But after we published the blog, actually, so since January, we've seen a steep decline in infections with this particular malware. And yeah, I think we made the a bit safer the environment with this, and it's not so spread anymore.
So, did you see, or if you saw any persistence techniques linked to this particular campaign from this actor?
Yes, actually, we saw persistence, right? With EMPTYSPACE, the malware was creating the registry run keys.
And scheduled tasks. So the malware was using scheduled tasks to run the Python scripts. The second runtime broker with the space at the end, it was a Python wrapper that was executing the scripts on launch. And yeah, this was created by the runtime, the first downloader that was pulling additional malware down.
And also there was persistence for the quiet board, the malware as well, for the backdoor.
Okay, thank you very much.
Any evasion techniques that
Sorry?
you noticed, defense evasion techniques?
I didn't get that.
On the malware, did you notice any evasion techniques?
Evasion.
In some cases, we've seen that the malware was not, it was checking if there were administrative rights and it will just stop or even delete itself in some cases. So most of the cases we'll just see runtime broker getting downloaded on the host and being idle. And when the user was reusing the USB, it was re-downloading the malware, and then if they had the administrative rights, it would download the further payloads from the Python script itself. That was one of the ones we've seen.
I'm not sure if you mentioned it on the beginning, but for this threat actor, are there any correlations to the Raspberry Robin behavior? Because what I have seen is like mostly similar to it.
Raspberry Robin.
Yeah.
Yeah, we've seen that one pretty often, but I think they're different. It's just they're using the same initial, the same infection vector with infecting the USB and then calling out to the domain.
But did you maybe also looked on the behavior of Raspberry Robin and to check, because they are having these link files and everything, but the behavior after it is a little bit different. And
no, not really. And for that one, we had detections in place. Like we've seen in the SOC, when we receive alerts from Raspberry Robin, it's pretty it's just in the initial phase where the USB the files on the USB executes for the first time. But this one was not detected whatsoever.
And just to add, for Raspberry Robin, most of the infections have the DLL or the files already, the payloads on the USB. So EDRs are good at picking up that up. So when the malware tries to load from the USB, it's just going to block it. However, in this case, because it's just using PowerShell, it was calling out, which might be a suspicious activity, administrative activity, and then it was downloading additional files from well-known sources. So it was kind of hitting itself into the infrastructure and then additional payloads. So evading the EDRs pretty much.
I think there's another one. It never works.
Yeah, I think it was from here. If they fixed it later. But
You mentioned that one version of the malware, the far left side on the slide, I forget which one, you mentioned that it did privilege escalation. I was wondering if you could tell us about the exact method they used for that.
For privilege escalation? Oh, so not here. I think it's mentioned actually on the slide. You're talking about the runtime broker, right? Oh, okay. Here.
Yes.
Which version are you asking about?
The Node.js one.
Node.js. I think that one was creating a registry key. But we didn't analyze this ourselves, so we have a specialized team for malware analysis. And just to make sure, check out the blog. It's mentioned there. Yeah, that's all? Okay.
Thank you.
Thank you.